It's obviously a variation question that they tell you the output, the function, is the sum of two parts. Two parts which mean that when you let fx, it should be equal to something plus something. And they say that the first part varies directly as x, that means k times x. And then the other part is varies directly as x squared, which means that another constant times x squared. But however, because there are two unknown, two constants, so we have to label k1 and k2. Beware that if the question say that fx is inversely various as x, then it should be k times 1 over x instead of just times x. But anyway, it's not included in the question, so we write down the first step is let. That means we know the structure of the function. This gives 1 mark. Where k1 and k2 are non-zero constant, but this one is not necessary. So we are going to use the result. They must give us some cases so that we can log the value of those constants. The first case is when x equal 2, then f2 is equal to 34. So we start from f2 34 is equal to k1 times 2, and then plus k2 times 2 square. We just substitute, replace f2 by 34, and then we replace x by 2 here. So 34 is equal to k1 plus 4k2. If you are not going to rely on your calculator, then you should try to simplify it. All numbers here are divisible by 2, so I try to divide both sides by 2 to make it easier. I can do whatever I want. Just make sure that it's fair enough. So 17 is equal to this item. Now we are going to do similar thing for the another part. When x is equal to 3, then fx will equal to 57, or f3 is equal to 57. Again, we substitute inside, then we have 57 equal to 3k1 plus 9k2. Similar reason, I know this is divisible by 3 and all items are divisible by 3, therefore I try to do so. Make the number smaller. This gives you 19, while this one is k1 plus 3k2. Usually for simultaneous equation, we will copy down in this way. And then we realize that one type of the term k1 and k1 are exactly the same. So by subtracting each other, this will finally become 0 and only one kind of unknown is left. Therefore, in your textbook, we will say that we use the equation 2 minus equation 1. Then we will have, just because I prefer positive, so I use this one minus this one, 19 minus 17 is equal to k1 minus k1, and then positive 3k2 minus 2k2. So that's why this is removed, and then we can handle equation with only one unknown. So k2 equal to 2. After we know one unknown, then it's easy. So maybe I choose to use the equation 1. Since 17 is equal to k1 plus 2k2, and we already know that k2 is 2. So k1 is 13. Finally, it's not enough. The question is asking for fx. So it's just help us to find out the constant, and then we still need to answer what is fx, how it is affected by x. So therefore, fx is equal to k1, which is 13x, plus k2 here, which is 2, x squared. We finish the calculation. And then in part B, we just solving certain equation, which is fx equal to 7. We should start from the question here. And then based on our understanding about fx, we are going to replace it and express in terms of x. So 13x plus 2x squared is equal to 17. Before we continue, we should think about what type of equation it is, because the type will affect our strategy to solve it. We find x squared, so this is quadratic equation, and the standard procedure is put everything to one side. So positive 2x squared and positive 13x. Afterward, we have 70 here, both sides minus 70. And then we create equal to 0 here. Afterward, you may just use your calculator formula 1 to get the answer, or if you want to solve it by using factor method, is also okay. But you may try more combination. I think it should be 2 times 10 to get 20 and then minus 7, so 2 times positive 10. Afterward, minus 7 times 1. So therefore, 2x minus 7 equal to 0, or x plus 10 equal to 0. If something times something gives 0, which means that at least one of the factor must be 0 to achieve this target. So x equal to 7 over 2, or x is equal to negative 10. Whenever we ask you to solve something, that means we require x is equal to something here. That's why we know that we already fulfill the requirement, and then that's the answer of this question.